Hi guys, today we're gonna look at how to solve a first order linear ordinary differential equation. Okay, so let's just cut right to the chase. These are all the topics that we'll be going over today. We're gonna look at a first order linear differential equation. The technique we'll use to solve this differential equation is integrating factor, and some other things you might want to know is U sub, uh, product rule, and power rule and reverse power rule. Okay, and remember that product rule is just when we take the derivative of the product, it can be represented by this rule. So the first things first, we want to get our first order linear differential equation into a certain form. And I'm going to rearrange such that it's in that desired form. Okay, and keep in mind that originally we had the first derivative in Leibniz notation, and we could also write it in prime notation like that. Okay, so what exactly is this special form? I'll write it more generally as so. Okay, so the cosine t corresponds with the q of t. The e to the negative t squared corresponds with the p of t. So this is a more general form of the first order linear ODE, and we want it in this form before we apply the technique of integrating factor. Okay, now that our linear ODE is in this form, what is the integrating factor? It's simply e to the integral of p of t. And as to why this works, we're really just exploiting a property of e, and we're exploiting the product rule in order to do this technique by integrating factor. Okay, so let's compute the integrating factor. So p of t is e to the negative t squared. Okay, and as to how we compute that integral, it's just by u substitution. So we keep e the same, because whenever we integrate or take the derivative of e, we just rewrite it again. And in the case of integrating, we're going to divide by the derivative of the inside function, okay? Reverse chain rule, okay? So if we're dividing, we get it as such. And don't add the plus c. We'll add it later. Okay, if you add the plus c now, you won't get the correct answer. So don't do it. Okay, so now that we found our integrating factor, we're going to multiply every term in our linear ODE, in our equation. We're going to multiply every term by that integrating factor. So let's do that. And if you were confused as to why this works, perhaps it'll be more clear once we have this all written out. Okay, now that we have that all written out, we can see it's simply just that equation before, right? equation before. It's the exact same thing, but we're multiplying every term by that integrating factor. It might be easier to see if instead of writing out the integrating factor in full, we just had mu of t, or even just mu written. And maybe it'll make the product rule more obvious. You're supposed to recognize the product rule here. That's what you're supposed to recognize. And okay, we'll ignore the other side for now. But do you notice the product rule? The output of the product rule? Say we wanted to take the derivative of fg. Just be, I guess we could have wrote it this way, but we could write it another way. We could write it as f times g prime plus f prime times g. Similarly, if we had mu times y, and we want to take the derivative of that product, we would get mu to y prime plus mu prime times y. Okay. Maybe you can see the correspondence. So now that you can see the product rule, let's rewrite this product rule output as, well, let's go backwards, right? To the original product, mu times y. Okay, so it's the same thing, we're just going backwards. Is equal to mu times cosine t. Okay. And if we integrate both sides, remember this is fundamental theorem of calculus, we reverse that differentiation with the integration. Differentiation and integration are inverse operations, they cancel. We get right back to the product. So mu of y is equal to this integral over here. Okay. And if we divide by mu, we would get 1 over the integrating factor times that integral. And I'm not going to compute this to just save time, but I guess if you really wanted to, you could write out what mu is, replace mu with that e to the big power. Okay, so this is how you would find the solution to the first order linear ODE by integrating factor.